So we've beaten the concept of continuity to death, but your calculus teacher doesn't want you to just know the concepts. He or she also wants you to be able to apply these concepts to solve some problems. In this video, we're going to go over some types of problems that you'll probably encounter. So you'll probably be asked to use limit rules to show that a function is continuous over a specified domain. Another way you could see this type of question worded could be check for continuity of f of x over, and they'll give you some interval. An example question of this type would be use limit rules to show that f of x equals x over cosine of x is continuous over the open interval negative pi over 2 to pi over 2. So I'm going to actually be showing an example for each of these types, and we will work each of these examples in other videos. Another type of problem you'll see is you'll be given a function and you'll be asked to identify where it's continuous. So for example, where is f of x equals 3 over x squared minus x continuous? Again, we'll be working this example in another video as well. Another type of question you may see is given a function, identify points of discontinuity and specify which of these are removable. Which of these is removable or which ones are removable. So say you're given the example f of x equals this piecewise defined function, so 1 plus x squared for x greater than 0, and sine of x over x for x less than 0. Identify, just abbreviated that ID, which point or points of identify a point or points of discontinuity and specify which one is or which ones are removable. So this is a two-part problem. You'll first have to find the points of discontinuity, the point or points of discontinuity, go through each of them and figure out which ones are removable, which ones are non-removable. So what another type of question you might see is what values of some constant c will make f of x continuous? And that could be either at a particular point x equals a, some interval a, b, and this is just a closed interval. You could be asked an open interval as well. Or you could be asked what value of c will make f of x continuous for all real values of x. So for example, let's say f of x is a piecewise defined function c squared minus x squared for x less than 0 and 2 times the quantity x minus c quantity squared for x greater than or equal to 0. And c is some real number, let's say an element of the real number system. This is a notation you might see for some real number. So this is the same thing as saying c is, or I should put a single quote here, c is some real number. Find c such that f of x is continuous for all values of x. And remember, if you have no idea how to go about this, we will be working this problem and others like it in future videos. And finally, you could be asked to apply the intermediate value theorem to show something. For example, apply the intermediate value theorem to show that x cubed plus x equals minus 1 for some x in the closed interval 0 to 1. And this is, these curly brackets here are just set notation. So for some x belonging to the set of numbers in the closed interval, set of real numbers in the closed interval between 0 and 1. And of course, last but not least, you could certainly be asked any number of application problems, and we will be going over some of these as well. So we'll be going over each of the examples cited under each of these 5 types of problems here, and we'll be going over some application problems as well. And at some point I'll get to more examples of each of these types of problems as well.